We're going to move now to financial considerations. Mark Mulligan is a reader in geography at the King's College London and a senior fellow at UNEP World Conservation Monitoring Centre, and he has developed a free tool called Costing Nature, and he's going to talk to us about using costing nature in this debate. Mark.
Okay, thank you very much. So I'm going to take you through a global analysis of biodiversity and ecosystem services that we protect, i.e. that's in protected areas, now under a 17% target and under half for nature, in order to try and understand how much of these things at a global scale we can protect in that way. And as was mentioned, the methods for this involve, first of all, using the World Database on Protected Areas that tells us the current distribution of protected areas, using this tool that you can also use for any protected area that you know about, or indeed at the national scale for your country, called Costing Nature, which brings together a wealth of remote sensing and geographical information on biodiversity and ecosystem services, pressures and threats. But instead of running it nationally, we've run it continentally with 1 kilometre resolution for the current situation of ecosystem service and biodiversity distribution. We've run it for the vast majority of the globe, but we can't go above 60 degrees north because we don't have the data for some of the services there. And what we're mapping is sites of production of ecosystem services that we are currently using. They're called realised services for water, carbon, hazard mitigation and nature-based tourism, which are the easiest ones for us to map at this kind of global scale and much more reliably than some of the other ones that we could have chosen. But we also look at geographical total richness and endemism based on the same data sets we heard about earlier, and we are calculating protection for each country or for each continent as a percent of the national, continental or global values for those services and that biodiversity. Oops. And this is the protected areas estate as it stands, and the black area is the area that we cover in the study, which is, as you see, most of it. And of course that estate has increased over time. You see 1950 up to 2014, the blue bars being the area globally protected. The lines that we see there in different colours are different ecosystem services and biodiversity. So the green line that you see at the top there is carbon stock, and you can see we protect more of the globe's carbon stock than the area protected. We're preferentially, if you like, protecting carbon stock. But if you look at the red line and the blue line, which are hazard mitigation and water services, we protect less services in percentage terms than we do in area terms. They are not selected for in the current protected areas estate. This rather groovy map contains lots of colours, and what it's showing is in different colours the extent to which we're protecting endemism, ecosystem services. So endemism is in green, richness is in red, and ecosystem services are in blue. So if pixels there, or if protected areas that you see there are green in colour, and you can see a few of those, that means that the thing that they're most protecting is endemism. If they're blue, like the ones in Europe, for example, or the Himalaya, what they're most protecting is ecosystem services. And so this tells you a little bit about the database behind the system. If they're white, like most of the Amazon, well, that's protecting everything. High richness, high endemism, high ecosystem service. Very valuable protected areas. But of course, as well as protecting biodiversity, endemism and ecosystem services, they protect a particular blend of ecosystem services. So here we have red means protection of hazards, mitigation services, blue is protection of water, green is protection of carbon. So if we have something that's very green, again like the Amazon, then actually the thing that it most protects is carbon, because the other two services are quite low. If something is blue, then even if it's in a desert, it has less carbon, less hazard mitigation than it does have water. And if it's pink, then it's protecting water and carbon. So you can see different parts protect different things. It's a complex picture. So what have we secured to date? Well, if we can look globally, that's the top line of this chart, and we can look continentally, which are the other rows. Globally, in 16% of the terrestrial surface area, we have protected, in quotes, 15% of global richness, 18% of endemism, 21% of tree cover, 21% of carbon stock, but only 15% of the water and hazard mitigation services that we actually use, and that we need to continue to use. And you can see the greens are above 17%, the reds are below 17%, and we're doing better at protecting some things than others, like vertebrate endemism and tree cover and carbon stock. Lots of green in there at the moment, but richness, hazard mitigation, water, lots of red, below the 17% target for protected areas. But of course that varies hugely nationally. If we zoom in for a minute away from the global scale and think nationally, each dot here on this diagram represents a country. The colour of the dot represents the proportion of its territory, land, that's protected. So red is 52% and blue is close to 0. Those countries within the red box are within 17%, below target. Those countries outside the red box are already above target, above 17% in terms of the area they protect, some of them very high. But what we can also see from the axes is that as you protect more area, as we go from blue to red, you capture more of the richness that those countries hold, and you capture more of the ecosystem services that those countries hold. So it's easy. You grow your network, you capture more. There are differences from country to country in what you capture, depending on where you put your protected areas, relative to socioeconomic and biophysical conditions, but that's the reality. What would 17% buy us? In short, not much more than we've already got. Right? 17% would, if we continue using the same kind of targeting of protected areas, we would protect 16% of global richness, 19% of endemism, 22% of tree cover and carbon stock, but only 16 and 15% of the critical water and hazard mitigation services that we currently use. And we need to actually protect 100% of those, otherwise we have to replace them with other things, grey infrastructure and so on. So we get more green at 17%, more above 17, but nowhere near 100. So let's think, what would 50% buy us? Well, the answer depends where we put that 50%. And we can visualize a whole series of future scenarios at 50%. So the top left here is a diagram which says, okay, where would protected areas be if we focus them on the 50% for each country, the 50% of land that produces the most ecosystem services. So within each country, green is top 50% producing ecosystem services, right? And red is lower than that. So if we chose those areas on the base of ecosystem services, we would get that pattern of protected areas at 50%. That's a lot of the world, as you can see. If we did it differently on the basis of species richness, we get a not dissimilar pattern globally, but subtle differences, as you can see, but a large part of the world. If we used agricultural suitability and said, let's just protect the poorest agricultural land in each country, the 50% worst agricultural land, we'd get the top left. That's what that would give us. And if we said, okay, let's think more strategically about areas that are high in biodiversity, high in ecosystem services, pressured at the moment and threatened in the future, then we would get this map on the bottom right here. More complex because it has more variables. So they are 50%, half for nature, landscapes that are hypothetical and of course ignore the distribution of ownership, tenure, people and so on, but give us some figures to play with. But what happens? We go back to our earlier diagram that goes from 1950 to 2014, and we have increased protected areas over that period, and we've increased our ecosystem services that we've secured. All of them: water, carbon, hazard mitigation, nature-based tourism, endemism and richness. But now we've added some extra scenarios. The first one, the first big block at 50%, is what we get if we distribute that 50% on the worst agricultural land. Well, we protect 50% of the area, but we get less than 50% of biodiversity, ecosystem services. Right? Was that one? Excellent. If we go by richness, as well as extra richness, more than 50% richness, we get more than 50% of all the ecosystem services. If we go by ecosystem services, you see we start to capture in some services more than 60, more than 70% of the services that we rely on. If we go for a random scenario or the conservation one that we looked at, it's again similar. So there are some figures to play with. What are my key messages? Well, we currently protect less than 16% of biodiversity and ecosystem services with our current network, or regional variation. As it's grown, we've selected for more protection of carbon, but less of water. We're protecting less and less of the water that we rely on. By targeting 17%, we'll get less than 17% of many of the ecosystem services that we need. If we follow half for nature, then we can protect between 50 and 60% of richness, 50 and 65% of endemism, 50 to 70% of the ecosystem services that we need. They can be within protected areas. Now, that doesn't mean they're actually protected, but it certainly helps. How much we protect depends on the location strategy for these PAs, and we will also, given that we need 100% of the ecosystem services that we're using, we will also need to manage land carefully outside of the protected area network, because even half for nature wouldn't give us all we need. Thank you.